So in this webinar, okay, first of all, let me introduce myself. My name is Adejumo Ridwan Suleiman. I'm going to be taking this current webinar, creating publication ready tables in R. So most of us maybe we had interest in this webinar either because we are publishing, that is, we actually write academic articles where we actually need to give tables, neat tables, summarize tables. So because most of the times there's a restriction on the number of tables you can use in a particular journal article. Please, if I'm not being heard, please people should try and signify, or if you are not seeing my screen, maybe possible network glitches at times. So if you want to create some of these tables, most of the times people still do this manually. That is after analyzing, maybe in R or even in SPSF, they do it manually just to arrange this table, because you can have various factors that are trying to analyze and a particular outcome variable or even several outcome variable, and you need to put all of this in a single way such that it's easy to present, maybe in just one table instead of scattering the table all over. Because when you have many tables, some tables you need to reduce the number of tables based on a journal article requirement. So one of the power of R is that it allows you to be able to create these publication ready tables straight up or direct. So you are able to create these tables direct without having to do any manual editing, maybe in Word or any other word processor that you're actually using. So you don't need to do any manual editing. You just analyze your data and get a ready-made table. So this is something that even SPSS also lacks, because sometimes too there's some complex table that I just need to do it manually and patch it manually inside SPSS. So we're going to be talking about this into this webinar. So there are a lot of packages that are usually used to create publication ready tables. So the interesting is that most of the times, most of these tables, you can actually create it yourself using the various basic packages that are available. But some packages have already been done or created to make it easy for anyone that is going to create such tables. After all, most of these tables just have similar formats. For example, if you are doing a chi-square analysis now, you're going to be having on your rows most of the, let's say, dependent variables, and in the columns you're going to be having your independent variable. Same also, you are trying to do a regression analysis, you're also going to be having on your rows your independent variables, and your column is going to be something like the odds ratio, your confidence interval, your p-value, or maybe your relative risks. So these formats are similar, and someone have already created some of these packages to make it easy for us. So we're going to be using these packages. These are the packages we're going to be using today. So you can see all of them here. We have this package called Pacman. So the thing with Pacman is that Pacman makes it easy for anybody that doesn't have a package installed in your system or in his or her PC to install those packages, because when you are using R, you need to install a package, and after installing that package, you need to load that particular package. So it's a different thing for you to install it, and after installing, it's a different thing for you to also load it. The Google Meet might take an hour because we are currently using a free Google Meet. So in case it cuts, so you people can rejoin using the same link. So the Pacman, once you have it, you just use the Pacman payload. So this double colon here is just referring to this function from that particular Pacman library. So if I've already loaded the Pacman library, then I might not need to use, if I've already loaded it using the library Pacman, so I might not need to call this particular column with the package name. So this is more or less like a shortcut. It's usually used when you're just using a single function in a particular package. But when you're trying to, if you're going to be using multiple functions from that particular package, then it's just better you just call it. Now this is where the Pacman now comes. So instead of you installing and calling, because most of the times you just need to comment to someone if it doesn't have a library, so you just use the Pacman. So this Pacman is going to take care of everything. Currently now, I already have all these packages on my system, But if I'm to give it to you, maybe you don't have all or you have some. So the Pacman is going to check it one by one. So if it finds out that you don't have the Rio, it's going to install it for you and load it. So which means you don't have to load that particular Rio package. Same thing too, also is going to follow it till the end. So it's a very important library, and it helps in reproducibility when sharing codes or collaborating with others. So we are going to be using the Rio package. The Rio package is for file imports. It's also another package or another way of importing a file. So because I'm just using an R object here. So these are our data, but it's in the form of an R object. So that's why I'm using this particular import function from the Rio package. So we have the here package is for locating a file inside your file directory. We have the scheme R. It's usually used for getting overview of a data. We have the tidyverse. So the tidyverse is also popular. It's for data management and data visualization. It encompasses a lot of libraries. So it's more or less like the tidyverse families of package. There are a lot of packages inside. So most of the times you just load it all to prevent loading other packages one by one. We have the gtsummary, which is actually the main library. The gtsummary allows you to create summary, statistics, and tests. So you automatically get a table you can export to Word. So this table, you can use it in your publication directly. We have the rstatic also. It's also similar to the gtsummary, but just some little differences. We have the janitor. So janitor is actually used for cleaning, or let's say for arranging tables. So most of the times, if you want to build cross tabulations, you use this particular janitor package. So to get your totals, to get your percentage. So these are things that it's going to help you to do. We have the scales. So it converts proportions to percent. It's also a lightweight package. So when you have your proportions, you are able to convert it to percent using the scales package. We have flex table. So the flex table is for converting tables to images. So if you want to convert tables to images, you use this flex table. So let's say it's because most of the times you are going to have your, what do they call it, table. It's going to help you convert it to image. So this is what this particular flex table does. So that's it for the libraries that we're going to be needing. So next line we have is our data we're going to be using. So I'm just going to run the whole of this session portion. Just going to click on this. So it's going to take time to load. So let's see. Okay, so I think it's already loaded. So let me confirm if this thing is being recorded. Okay. Okay. So now I'm going to just view the line list. We're going to be using the line list data. So I'm calling the view command to open it up in another tab to view the data. This is the line list data. It's a fictional data on Ebola. So it's not real data. It's just like more or less like a practice data set related to epidemic. So this is just a fictional Ebola data. You can see we have case ID. So more or less like each row is for a particular patient. We have the generation, the date of infection, the date of onset, hospitalization, date outcome. We have the gender. We have the age unit. That is the unit of the age. Is it in years or in months? We have the age in years. We have the age category. So you can see these are all the other columns. We also have the longitude and the latitude. We have the hospital where the case is coming from. You can also see the age categorized. These are already grouped. We have the infector. So the infector is more or less like the person that was basically so let's say more or less like where because this is an infectious disease. So we have the source, the weight, the height, the blood count, fever, chills, cough, aches, vomit, temp, time admission, BMI, and days onset. So this is just an overview of our data. So we're going to be using this data to create some statistical tables. So I think I just have the warning. Okay, So now we're going to be using the scheme function to get information about each variable in a data set. So when you're working with the data, it's best to have an overview. Earlier on, what we just did now is just an overview on the content of the data. But now I want to have an overview of the variable types, the presence of missing values, and also other things. So I'm just going to run this. And we use the scheme function from the scheme R package. Now you can see we have various tables here. This is what you get anytime you apply the scheme function on a particular data set. First of all, we have our data summary. You can see this is the name that we gave it, the number of rows, 5,888. We have the number of columns, which is 30. We also have the column type frequency. So out of our columns that we have all the variables, 13 of them are characters, 4 of them is dates, and we have 2 of them are factor, and 11 of them is numeric. So this is just an overview. We also have the next table now. So this next table now that you can look at, you are seeing now, we are having some of the variables here. So I think this one should be for, okay, if you look at it here, we have 4 column types. So it's going to give you a table for each column type. So this first one here is for character. So we have the case ID here. You can see there is no missing case ID. The complete rate is 1.0 because there is no missing values under the case ID. So we have the minimum, we have the maximum, we have empty. So this minimum and maximum is the number of characters in that particular string. So just like the number of, let's say for example, we have a case ID of XGY. So just saying 3. So something like that. So all of them are having equal length. It's just like the length of the character. So this is what this is just talking about. We have the empty column. We have the number of unique values. We have white space because it's a character. And okay, so this is it for each particular column variable that we have, or each particular column in our data set. So the next now, I think that should be for the dates. So the next is for the dates. So date of infection. So out of date of infection, we have 2087 missing. Complete rate is 0.65. Then we have the minimum. This is the minimum date there, and this is the maximum date in that particular column. We also have the median, and we have the number of unique values. So this is for these dates. These are for the dates columns. The next we have is the let me see, this should be the factor. Yes, this is the factor. So we have just 2 factors. So factor and character is actually 2 different data types in R. So when we talk of factor, we're talking of categorical. And most of the times, if you want to convert an analysis, any variable that you know is a factor, you need to convert it to a factor data type before you should use that particular variable. So you're going to get, so the R is going to recognize it and give you accurate output. So we have the number of missing, we have the complete rate, and we have ordered. Hope everyone is with me.
Yes, sir.
Okay. So we have ordered, we have the number of unique, and you can see also have number of unique, top counts, ordered, complete rate. So this is just also an overview of the factor. Then we have this particular, these are numeric. So these are numeric is 11. So these are the numeric values that we have. We have generation. So same thing also, we have the number of missing, complete rates, the mean, the standard deviation. And because we are talking of numeric, we have the first quartile. Sorry, this is... Please, can you mute your mic? Please, can you mute your mic? Okay. These are the percentiles. This is the 25th percentile, 50th percentile, 75th percentile. So this is 0th percentile. So these are also measures of, these are various measures of partition that we have. We also have the hundredths here. So we have the histogram. This histogram is just more or less like an overview. This scheme is a very important function. Anytime you're working with the data in R, it's always good to use the scheme. You're able to get the nature of your data sets and also how you can handle the missing values. It's more or less like you are exploring the nature of the data sets, how it was, how the data set is appearing, and what are your variables that are going to be working with. So that's it for the scheme. So now I want to get an information about each column in a data set. So this is the base R function of getting a summary of a data. So this is not as comprehensive as the scheme. So it's not as comprehensive as the scheme, but it also gives a summary overview. As you can see it, anywhere there is a numeric is going to be given the various measures of central tendency and the measures of partition. So you are going to be seeing them in those that are numeric, but in those that are character, you're not going to see any of that information. But you can see another problem is not recognizing that of date. So you can see it's giving some information which are not accurate, like N is for date. So it's recommended that when you are using or you want to explore data, use the scheme function. So you can use the base R to get summary statistics by variable. So just like that summary function is earlier on, you just use the $sign to refer to your column. So one thing with R is that once you just type the $sign in the front of a data set name, it's going to give you the list of all the variables they are going to be dealing with. So you can see we're having a list. So you can get a summary individually for each particular variable that you are interested in. So when I run this now, you can see that I'm able to have my mean, minimum, the first quartile, the median, the mean, the third quartile, the maximum, and also NAs. So these are the various information I have by just accessing one variable. Still this same information, but this time around, I'm just referring to a particular variable. If I want to pick, let's say for example now, the second element here, I'm going to be using this particular square brackets. So since it's the second element, I'm just going to enter this and I get 6. So if you can look at this, you can see that the value of the first quarter is actually 6. So the reason why I'm bringing all this out is because most of the times these are the kind of things you might need when you want to construct your descriptive tables, and you can see how tedious it is. So, and also another alternative to the above, you can see we have this first quartile. You just refer it to the name also, and you can also get your output, which is 6. So now we have the get summary stats. So this is the get summary stats function that allows also that returns a summary statistic. So if we run this now, we get a summary statistics for each of these particular variables. So I think the get summary stats, let me see, it should belong to the package name. Yeah, it's under the rstatic package. So the get summary stat is under the rstatic package. So this is more or less like a shortcut on getting all your variable, your descriptives about your particular numeric variables. If you look at it here, we're using what we call a type is equals to common. So if you look at this argument here, we have various type of summary statistics that is going to return. We have full, we have common, we have robust, we have 5 number, we have mean, standard deviation. Each of these options depends on the kind of summary statistics that you are interested in. So we have already selected our line list. So we just use the pipe operator. For anybody that is not familiar with the pipe operator, this is called the base R pipe operator. So we have that of the tidyverse, which is actually like this. So sometimes you might see this, sometimes you might see this. So if you are not familiar with it, this is a pipe operator and allows you to be able to apply a particular data set or maybe a particular variable to a function. So this type common now is various type of summary statistics. If you take a look at this now, we have the number, we have the minimum, we have the maximum, we have the median, IQR, the mean, standard deviation, standard error, and the confidence interval. So let's say we give it a value of full. What do we have? So you can see we're having other informations that we don't have in the previous one. If I give it a value of mean SD, so this is the mean SD here. There's also another type I could give. You can see I only get the number, the mean, and the standard deviation. So this is how you can also use this particular get summary stats from the rstatic to able to get summary from or descriptive summaries from your numeric data. So now we have the janitor package. So janitor package, I've already explained this earlier on, mostly helps in creating cross tables. It makes it easy to be able to create cross table. Like look at this example now. This is my line list. And what I just did with my line list, I use this, what I just did now with this particular data, I use the table function. The table function from the janitor package allows you to be able to calculate proportions from the values of a particular factor. I have my age category with various age category, and I want to know the proportion of each particular age category, or let's say the number. After knowing the number of each age category, I want to also know the proportion or the percentage of each age category among all of them. So if you use the table function, you are able to get that. There are various arguments that we have in the table function that allows you, if you don't want to include this particular NA, because it's also going to count NA for you, because you might have NA which is missing values. So if you don't want to include your missing values, we have the arguments. So if you go to the table function, it's very important when you are working with R, you always take a look at your functions so that you know the various arguments. So this is the show NA. You can see it says should count of NA value be displayed in a one-way table. So this is if you want to set your NA true or false. You can either give it true or false. So if I should say show NA is equals to false, so you can see that the NA is not there. So it has already removed the NA. So let's have a look at it now. Do we still have the same proportions just like earlier on? So let's see it. Look at our two values. So you can see that it's still maintaining the same proportions. It's just that it just eliminated what? The NA. So this is how you can use the table function. So if you want to just get a quick data about a particular factor variable, you can use that particular table function from the janitor package. So we have another one here. So this is more or less like a cross tab. So if you are familiar with chi-square, so mostly we use cross tabulations to perform chi-square analysis. So unlike the other one that we just showed the various categories for a single column or single variable, this time I'm going to be having a cross tabulation where another variable is going to be the columns. So let's have a look at this. So you can see that female and males, and for the rows we have the age categories. So this is an example of a cross tabulation. If you don't want NA, you can remove that NA using the arguments I just explained earlier on. Before I proceed, is there any need for clarification or questions?
Please, sir, can this particular class be recorded so
Yes,
that we'll be able to?
It's currently recorded. Yes, I'm currently recording it. Okay. So, I can proceed, right?
Yes.
Okay. So we have other functions too in the janitor package. It's also useful because if you can look at this, we just get counts. Sometimes we might need the proportions or the percentage. So we have this particular, if you look at this, we call it add-on PCT formatting function. You are going to pipe it, that is, you pipe your table to this particular add-on PCT formatting. So what this is going to just do for you is going to format your table and give you percentages. If you can see it, so you can see I'm already having percentages. It's not the only one. We also have add-on totals. If I use add-on totals, so you can see we have add-on totals here, and we have, okay, so for example now, if let's make use of another variable now, gender. So it's going to, you can see the previous one did not have this total, so this is going to include the total for you. Now if you look at this total, the total is actually column based. So this is where you have some arguments. We have where, the argument where. So this where can be column or row. Currently now it's column, so let's make it row. So okay, let's see the column. Okay, so this is it. So when you add it column by column, you follow it column by column, you are going to be getting your total. So this is where you use this argument where is equals to column. But if you want it to be, you want to follow it row by row, you use where is equals to row. Then we have where is equals to both. So where is equals to both is going to give for both the column and the rows. So this is for the add-on totals. And we also have for the add-on percentages. So the add-on percentages, you can see, you can also give denominator. It also has an argument. Denominator is equals to row, column, or all. So let's say denominator is equals to all. So this denominator means that let's say you are going to add everything and get that particular, let's say you add a column, we're going to be taking the proportion, is it column wise, or we're going to be taking it row wise. So this is it for the add-on percentages. Same thing to also for the add-on PCT formatting, which was what we used earlier on. So most of the times you might just be using the add-on PCT formatting. So the add-on PCT formatting, it actually gives you the percentage. I think I'm having some issues. This value is not. Let me run this again and see. Okay, let me see. Okay, so now if we have a single variable now, each category, you can see our number and also the percentage. So valid percents are those that are not missing. So anyone that is missing is not a valid percent. So this is what we have. So let's say if we have gender now, gender. So we have gender. I think you might need to make some settings in the function. PCT formatting. Okay. Okay, I think I know where the issue happened. So this is the next code that fixed what was happening earlier on. So one thing with the function is that you need to use them. Let me just leave this. Okay, let me just leave this as the percentages. You need to arrange them. If you look at the next example now, you can see first of all we did add-on totals where row. So let me just say I pick this. You can see when you run this, we have where is equals to row. So we are going to be getting the totals. We are going to be row by row. Now we are now going to what are done with its percentages. So this time I'm now going to add percentages to it. So that's why it's very important to understand these pipe operators. So I'm going to add done with its percentages after getting that particular totals, as you could see. So these percentages is actually going to be given you in proportions. So this is where the add-on PCT formatting will now come into place. When you now run it, you now have your percentages. You can see these are the correct percentage that we are having. Now, if you look at this now, everything is going what? You can see we're having for this place, we have the total, which is we have the total here, 47.7, 47.6%. We have 4.7%. So when you add all of them here, you should be having what? 100. So this is more or less like the percentage of the females, the percentage of the males, percentage of the any. So if you want to get all, you could just, if you want to get all of them, let's try all. Okay, it should be both, and percentages should be all. Are we there?
Yes, sir.
Okay. Okay, so this is it. The total. This is it. When you look at it, this is the total for the row. When you look at it column by column, when you add it by column, you get this column totals, and this is the row totals. So this is more or less like a complete table, which most of the times you can see in publications. So this is just more or less like a summary on what the capabilities of this particular janitor package. We also have another example here now. First of all, we have the table. So we just create our table first. We create our table, our cross table. After creating our cross table, then we put our totals. So these are our totals, as you could see it. After putting our totals, then you put our percentages. You can see our percentages. So you can see more or less, it is more or less like a chain. And after putting our percentages, we use this add-on PCT formatting because these are just proportions. So we want it to be in percent. You can see it. So this is it in percent. Then we can now add on the position. So if you look at this, so you can see how it is different from what we have earlier on. It has already put the percentage. This add-on NS position is go to front. It's going to put the percentage in the front. So this count is going to be by the side. The percentage is going to be in the front. So this is also one of the functions of the janitor. Then we now have add-on title. So you're now going to give it proper title, age category and gender, instead of using the variable name. So you can see age, we have the age category, we have the gender. So this add-on title is not going to be using the variable name. You are going to give it a default name, just like if you are plotting a plot. Now the next one too, also this is also similar to what we have done. So in the last one, this is also where we stopped. So this is just what the new thing that we're adding. Now this is a table, but you can't use this table directly inside Word. You just have to copy and paste it and create a new table and impute it. But R has already made that easier. If you look at this now, we're going to be using the flex table package now, and also the auto-fit function. So first of all, let me just show you how the flex table works. So you can see what we have now currently. We have age category and we have gender, female, male, and this. So these are the various variables that we are working with. Now, that is where this now comes into place, this auto fits, because we want everything to be in one line, both the count and the percentage. So if I just run this, so is everybody seeing this?
Yes.
Yes, sir. But what did you do that you get this?
Yes, that's what I'm saying. I don't know. Was this side clear? Was this place clear?
Yes, yes, yes.
Okay.
It
Now
was like this,
these the
but
two
how?
things I just added. These the two things I added. Flex table allows you to be able to
Okay.
convert tables to images. Flex table. It allows you to convert tables to
Okay,
images.
flexible.
So this auto fit,
Okay.
what this auto fit does is that it makes it more neat. You can see earlier on without the auto fit.
Okay.
If I should just
Yes,
use only
yes,
the flex table, you can see that it's somehow jam-packed. You can see it.
yes.
So,
Yes. Yeah, yeah.
that's what that auto fit does. So the auto fit allows you to be able to put everything in one row, so it becomes more cleaner.
Okay, yeah.
Okay. So now these missing values we will not be using it in our table. So this is where you can now remove it. Just like what we did earlier on. This is the only thing that we are adding now. You can see it.
Yeah.
This is the only thing that we are adding to remove our missing values. This is the filter function from the dplyr package. So we are going to filter only values that are not NA, that is, that are not missing. And we also filter gender, that is for each category, the first one. Then the second one is for gender. We are going to filter only gender that are not missing. This is the only change that was made to the code above. So once we do that now, and I run it, so you can see that that particular missing column is gone.
Yes.
So that is the change that we just made to this code compared to the previous one.
Yeah.
So this is also
Yeah.
this is just another simple examples too also. So I think we have already treated this, just showing how the add-on totals work. So if you want to count, also you can count an hospital and use the add-on totals to get the total. Now another important thing is that you also need to get this table into Microsoft Word, because you cannot just paste it as an image in Microsoft Word. So we also have a function that once it exports it, you can even edit it in Microsoft Word also, where you can maybe change your, for example, you can want to change your category labels. So this is where we can now export it to Microsoft Word. This is what we are adding here. This is just the new thing that we are adding compared to the previous one. This is just the additional that we are putting.
Okay, doc.
Yes, yes, this is what we are just putting. Save as doc. We have other ones, save as HTML, save as Word, save as PowerPoint, save as PPT is PowerPoint, then save as image. So anyone that you are using, make sure you use the right extension to avoid error. If you are using PowerPoint, you make sure you put PPT there, so that it's going to be saved as a Microsoft PowerPoint. If you are using HTML, you use it as .html. But the most common one that you'll be using mostly is the doc. So once you save it as doc, it's going to be saved inside your directory that you are working. That is your particular R directory. Tabil.doc is what we are going to save it as. So once I just click this.
Okay.
Now, if I go to my file, you are going to see it here. This is it. So let me open it.
Okay.
So this is the table. Can everybody see it? And you can see that it's editable.
Yes.
It's not just an image, it's editable.
Yes, yes.
So this is the table. So this is one of what you can do with combination of the janitor package and flex table. Okay. Now, that is just for descriptive, maybe your descriptive table, which is mostly the first table in a publication. We also have, if you want to conduct a chi-square test now, so you can use the table to create your cross table, and you use the chi-square test on your table. That is on your particular table table. But the thing is that this one will not run if you don't use this particular argument. It will not run, because don't forget that if you don't put this argument, you are going to be having a table with missing values. That's what I said earlier on. So when I run this, you can see that missing values in row.names are not allowed, because if I should view it now, if I should view age by outcome, you can see that it is having missing values. So that is why if you want to run a chi-square, make sure your table doesn't have those missing values. So I'm going to be returning this argument, and you can successfully run a chi-square. So this is our chi-square test. We'll also come to the way you create a chi-square table that you can just export to Word directly. But this is just to show you how you can apply your base R chi-square to your cross table that you created using the table function. Okay, so now this is the dplyr package. We can also use the dplyr package also. It helps a lot in creating summary. We are going to use the summarize function now to get summary of our variables. If I should run this now, you can see n rows is equals to n. So this summarize just summarize the whole data and give me the number of rows. But if I want to get the number of rows for a particular category, I need to use the group by function. So what the group by does is that you are telling it that I have a variable called each category. I want you to group this variable. But the group by function itself doesn't work alone. You need to join it with the summarize. It's always go in hand with the summarize, more or less like a twin with it. Because you are just giving the group by command to tell R that group it, but the next command that is following that is going to be giving me the results by that particular grouping. So now, if I should run this now, you can see each of my 8 categories. This is the number of rows that I'm having.
Yes.
Now, this is also a shortcut to what I just did earlier on. We have the count function. So instead of just going through this process of grouping, then using the summarize, you just count. But the count is going to give your number of counts a default name of n. That's going to be the default name of your count.
Okay.
Yes. Then we have the line lists. Okay, so we have to change the name. You can use this argument. Name is equals to count. So when I run this, you can see I'm still having the same thing, but this time around, I'm having a new variable name called count instead of n. So this name is equals to count belongs to this particular age category. Now, one important thing is that we already have the gtsummary package for most of all of these things. gtsummary can just use one line to create a full table. But the thing is that sometimes there are some customizations that might not be available. So you might need to use some of these packages that I'm showing. Then that's where you now use the flex table, because it's the flex table that makes it easy for you to carry that particular table to Microsoft Word. It's that particular flex table that allows you that makes it easy for the table to appear in Word. So this is also another example of that's count function. So this is also going to count each category. So what this does is that the count function first of all starts grouping from the age category, then the outcome. So those that are age 0 to 4 and the outcome is death, this is their number, 471. If I should change it now, outcome age category. Outcome age category. So you can see that it has already swapped. Those that are dead, age 0 to 4 is 471. So this is more or less like the first grouping that was considered, then the age category. So ordering also matters while you're inside the count function. If you want to show all levels, use the dot drop is equals to false. So if I should run this now, it's going to show all levels. Now, what this all levels means is that a particular variable or factor might contain a level, because in R you can assign a factor levels, but it's possible that in the whole of that data, that particular level is not there. For example, now, if you have a factor called gender, you have male, female, and you have another factor, let's say for example now, don't know. Let's put it like that. Now, when creating that particular factor, don't know, R has already recognized don't know to be a label. But it's possible that in your data set there is no a single don't know. So that is where we have that particular show all levels. Also, most of the times by default, your missing values will not even show. That's why you can see earlier on when I run this, the NA were not showing. Okay, sorry, the NA will show, but most of the times the issue we face is mostly with a particular level that is not what recognized. Just like that example I gave earlier on, the NA is going to show. So any level that doesn't show, it means that that particular level is not in the data set, just like the don't know I mentioned. So when you have don't know that was recognized in R to be a factor, then inside the data there is no a single don't know. So it's going to tell you that do you want to show all the levels, or you want to hide some of those particular levels that are not showing. So is everybody seeing my screen? Okay, nobody see my screen, right?
Yeah.
Okay, please can you mute? Can everybody see now? Is everyone seeing?
Yes.
Okay. Okay, so I think everybody should be able to join you now without an issue. Okay, so now also the count, still based on the count, we can also use the count to create the same tables we have created earlier on if you don't want to use the janitor. So this is a example that we have now. First of all, you call the count, and I told that the count is just going to give you the number. The count is going to give you the number of that particular categories under that variable. Then we call the mutate function. The mutate function allows you to create a new column. It's a dplyr function for creating a new column or new variable. Now, the reason why we're using this particular scales, if you remember earlier on, I told you that we're going to use a library called scales. And this percent function is part of the scales library. So this percent is going to what? Create, once we take a number, what we are doing here is that, okay, let me just remove this. So that we just see what's happening here. So this is what is happening. It's going to take each number here and divide it by the total. So from year to year, it's going to add it and divide each number by the total. So this is why we're having this particular proportion here. Then we want to convert it to percent. That's where we now use that particular scales. So this is where we now convert it to percent using the scales percent. So you can see it. This is how we convert it to percentage. So is everyone with me?
Yes.
Okay. Now I want to calculate proportions within a group. Just like what we did earlier on, you group by outcome. You count that particular outcome. So what we are doing now, I want to calculate the proportion within a group. So this is different. We have a group, but instead of calculating that particular proportion, we are calculating proportion within that particular group. So it's more or less like we're grouping by outcome. So after taking the count now, we're now counting based on that particular group. So let's have a look at what's happening. Let me just cut this and run this. Okay, we need to call the age out. by outcome. Okay. Age by outcome. Now you can see this. We have N. We have our age category. We have date. What I do now, I'm calculating. You can see this is age category under what? The outcome. So under age category, we have under 0 to 4 years outcome date, we have 471, just like what we showed earlier on. Now, if you want to calculate the percentage, this guy will do it. Age by outcome. If you look at this, the difference or what we are doing in this place is that this is the whole of dates. If you add all of this, you should get what? 100%. So we are actually calculating the proportion by group. We are calculating the proportion by group. That's what we just did in this particular place. Let's see if we use the count. Do we have the same thing? Let's just imagine we have cleared this. Let's say we have cleared this and we have, okay, we have outcome. You now have each category. Let's see whether we are going to have the same thing. I think most of you can see what's happening here now. This time around now, we are not getting proportion by group. This is what? Total proportion. So what this is just doing for us is just giving us those that are age 0 to 4 and are dates. This is their proportion from the whole of the people or the whole of the patients. But what we did earlier on, we are getting proportion by group. So which means what? We are considering those that are dates as a whole. We are going to get the number of those that are already number of each category under dates, and we have that of recover. So those have also recover as a whole. Even NA2 also as a whole. So we are getting what? Proportions or percentage by a particular category. So now this also allows us to be able to what? Plot the information we have earlier on. So this is the ggplot function for plotting. You can see that we have our dates, we have the recover, we have the NA, and we have the total number of dates under each particular category. This legend that we have here is for the age category. So each particular color represents a particular age category. So this information and this information are similar. It's just that we need to go a extra step further because here we are not plotting. But ggplot automatically recognizes that because of this particular argument, fill. So that is why ggplot is able to recognize this. So by doing this, the information we have here is also the same information you just have in this particular place. So we can also use the summarize with various statistical functions. If you want to use the summarize with various statistical functions, for example, now we have just been using summarize earlier on for maybe count. I think, where is it? So for n rows, you want to count the number of rows. But if you want to calculate various statistical functions, like your number, which is you're going to use the n function. You have the maximum. You can use it inside your summarize function. We have the round. You want to round up a number. We have the sum. You want to sum. We have also used this, which is the percent, which belongs to the scales. So you can use any of these inside a summarize function. This particular one that you are seeing here is the number of cases for this particular group. We are grouping by hospital. So this is the number of cases. So the number of cases is 454. You can see which is what represented as, which we calculated using n. Now, this is our grouping, which is by hospital. Then we have delay maximum. So we have a variable called days onset in hospital. And we're going to be removing any NA using this particular argument. So under that day onset variable, we are going to be getting the maximum. So that maximum is what? Is 12 for each hospital. Then we have the mean, the daily mean, which are going to calculate using the mean function. And it's always important to use this na.rm. The na.rm means that you should remove missing values. And the digit is 1. We are using this digit is 1 because we are using the roundup function. Look at it. The function can look a little bit clumsy, but look at it. This digit is equal to 1, belongs to the round function. So that is why you can see we're having to 1 decimal place. If I say 2 now, we're going to be having it in 2 to the 2 decimal points. You can see it here. The same thing too also happens in this place. This time around, the standard deviation that we're calculating, delay standard deviation. We also have day onset greater than or equals to 3. So we have a variable called day onset in the hospital. So any of those particular rows with delay that is more than or equals to 3, you should sum it. And once you sum it, we are going to be having the value here. So then we have our percentage. So these I can get a summarized table. So these tables are very important because at times you might not be able to do this customly from a particular package. So after doing this, you can now follow the same procedure we did earlier on. You use flex table and you can export it to Microsoft Word. So for example, now you can see something like this now. Day onset in hospital greater than or equals to 3. So anywhere that we have the day onset or any patient with the day onset in the hospital greater than or equals to 3. So what it's going to do for that patient is going to sum it and it's going to what? Give the values here. Then we have our percentage. So this is our summary table. So if you want to print it or export it to Microsoft Word, you just use the flex table package. Just use that particular flex table function, flex table autofit, and save as doc. Just 3 lines, and you can take your table directly to Word format. So in the summary statistics, you can also use conditions. Like if you look at this now, this is the summarize function. Also, it can also take conditions. So the summarize can actually take a lot of things because it's more or less like summarizing your data based on various factors or conditions. The simplest you can have is your number of rows. You can also check for particular patients that is above a certain age category or below a certain age category. For example, now if you look at this now, you can see we are looking for the what? Maximum temperature. So we are looking at fever is equals to yes. Anybody that have fever, first of all, we are filtering that person within that part, this square bracket. Now, this particular temperature now, we are now going to what? Select the temperature variable. So here's our data. You can see that we have fever. Yes, no, no, no. So some of them have fever. Yes, it's going to signify with yes. Then we have the temperature variable. So what this is doing now is that, first of all, we are looking at patients that have fever. Then we now look at the maximum temperature among those patients. So this is the filtering that we are doing in this place now. We first of all look at patients that have fever and the maximum temperature among those patients. Then the next table that we have is patients that don't have fever and the maximum temperature among those patients. And we have to make sure we remove NA in all of those particular summary statistics we are trying to get to avoid error. So you can see that this is the information that we are having. Is everyone with me? Hello?
Yes, sir.
Okay.
Hello. Yeah.
Okay. Now, we now have, so another interesting thing is that if you look at most of our tables, even want to export it to Word, we can export it like this. So this is where we can glue them together. So you can see, if you look at this, so you can see what we're having now. We are giving what each particular, most of those columns that we created, we are renaming them. So first of all, summary table. This is the summary table we created earlier on. I think this is it. So this is our summary table. If you could still remember, this is our summary table of hospitals with various new variables that we're creating. Now, out of these new variables now, we now want to glue them together. You can see something here. We created mean, we created standard deviation. So most of the times in tables, they're usually together. So the standard deviation can usually be in brackets. So that is where we now use this this line of code comes into place. We use this particular str glue function. This glue function is going to combine two newly created variables into a single variable. Not necessarily new created variable, it can even be variables in your data. It's going to convert them into a new single variable. Now, why you are using this is that you are using this particular curly bracket. You are telling R that this item I'm writing here is actually the name of my column. So if you make a mistake, you are going to get error. R is going to tell you that I do not identify any column with this particular name. So without this curly bracket, it's just a normal string that R is going to take it as. But this curly bracket will indicate to R that this is actually the name of a column. And you should combine these two columns together to create a new column called mutate. So if I should just pick this and I run it, so you can see, okay, what is happening? Okay, this is it, delay. So this is it. You can see it here. You can see that this is the new column that we have. Now, you can decide to select. We are going to select. So this select function is part of the dplyr. It allows you to be able to either remove a column or add or select a column or drop a column. Now, if I should just remove this minus, I'm going to be selecting the whole column by removing that minus. Can you see it's only those columns that I selected? But this minus means that I should drop, since I've already combined them into a single variable called delay, then I don't need these columns again, so I'm going to drop them. So by using that minus, I'm going to drop them, and when I run it, you can see how delay is appearing here. Now we have add-on totals. So this is the add-on totals that we have explained earlier on, because I've already selected some of the columns that we want. So we are adorning the totals. We are getting the totals row by row. So you can see it is row by row. We are going to get the totals row by row. It's going to add everything and give us the totals down. And now we are now going to select the columns that we're interested in. But when selecting it, we are going to be renaming it. And if you want to, you can use the select to rename. On your left-hand side is going to be your name that you want, which is actually going to be in quotations, is a character or string. Then on the right-hand side is going to be the name of your variable inside that particular data that you are working with. So you can see hospital name. We are giving it hospital name. These cases, I made it to be cases. Maximum delay is delay max. Mean standard deviation is delay. Delay 3 plus days is delay 3. Delay 3 plus days is PCT delay 3. So we have already renamed it. Then if you run this, so you can see that we already have proper column names on our data. So now you can decide to export this to your Word document if you choose, if you so wish. We have next is the percentile. You can also use the summarize function. You can use the quantile. So the importance of this is that at times your data might come. If you have any of you have worked on a project before, your ages will just come as numeric values, and at times you need to categorize it. So this is where this particular quantile function is very, very important. You can use the quantile function to group into quartiles, percentiles, deciles, tertiles. So any category you want to group in, you can use this particular quantile function. It's a very powerful function. It's mostly used in categorizing variables from numeric to category. And you can use the summarize function with it. Like now, you can look at our age in years. Our age in years is in numeric, if you can remember. Our age in years is in numeric. This is it. And to want to create a category for it, imagine we don't have a category. And we are going to be removing missing values. So you can see it now. Summarize. It's supposed to. Okay, so we have 5 rows. By default, it's going to categorize it for you into this that you are looking at. You can see 5. This is by default what you have: 0%, 25%, 50%, 75%, and 100% in percentiles. So the 25th percentile is 6, 50th percentile is 13, 75th percentile is 23, 100th percentile is 84. So we can say any value that is between 50 and 75, we can say is above the 50th percentile but below the 75th percentile. Now, you can also manually specify percentile values. You can manually specify yours if you want. You use this particular, just the same thing that we did here. But this time around, we're adding this argument. We're adding props, which is probability. So 0.05, which is 5 percentile. 0. Which is 5% of the 5 percentile. We have 0.5, which is 50th percentile. We have 0.75, which is 75th percentile. And we have 0.98, which is 98th percentile. So this is more or less like you're giving your own custom percentile. You're not using the one that is provided by R by default. So when you group it, these are the values that you get. So these are what you can see, that this is now your one. This one is your 50th percentile. 13 is your 50th percentile, which is also the median. 23 is your 75th percentile. 48 is your 98th percentile. So if you want to get manually specified percentile values of 5%, 50%, 75%, and 98%, this is also another way. You can see it. This is also another approach, but this time around now, you are getting columns. You are getting columns for a particular category. If you look at this, you can see this. We just put the age in years inside the summarize function. But what we just did now, we first of all group the data and apply the summarize. Now, which means that each of these particular percentile values, I'm going to be getting it for each hospital. So instead of just having something like this, as you can see now, I'm now going to be creating a column for each of them, and we're going to be having for each particular hospital. We can also do that for the if you look at it now, we actually grouped the age in years by hospital. So earlier on that we did not use any grouping or the hospital grouping, we just have the percentile values. If you look at this now, we have the 5 percentile, 50th percentile, we have the 50th, the 75th, 98th for each respective hospital. You can also change it and apply another category. So let's see outcome. If I see outcome, so this is it for the outcome. So just like what we did earlier on. So this is also another way you can use to derive information, or another way of trying to use the percentiles to get information from your data set. This is also now another way. The rstatic, more like a shortcut. The rstatic package has the function called getSummaryStats. I think we talked about this earlier on in the beginning. So the type is going to be quantile. Once you specify that type as quantile, that time when I was talking about common, full, I don't know if any of us still remember earlier on when I began. So I was talking about this particular getSummaryStats function. We have common, we have various types that you can actually put. So you can actually, this is more or less like a shortcut to what we just did in this place. You can also use that to get your percentiles. So this can help you in grouping your age. So you can just group your age and say, okay, this particular age group, for example, now you can group your age on less than 1, then you can say 2 to 13, then you can say 14 to 23, then you can say 24 to 48. So that's one of the important things with percentage. It groups your data equally. And a rule of thumb is mostly that your grouping should be a little bit wide if possible. So because more of the times you can get more information when you have more groups, let's say 4, than to have a group of 2 or 3. Okay, so we have summarized aggregated data. I want to summarize your aggregated data. Like now, this is a example that we have now. If you look at this now, this is an aggregated data. First of all, we chain our line list. We first of all drop missing values that are under the gender and outcome columns only. Then we now count it. So this is an aggregated data. Now we can now summarize this particular aggregated data using this summarize function. So we're going to sum the total cases. We're going to have a column called total cases where we sum all of these cases. So let's run it and see. Let me run all. So if you look at this now, first of all, total cases, the total number of cases under each group. We're going to sum the total number of cases. I've already grouped it by outcome already. So total cases, total number of cases under each group. Then total number of male cases under each group too also. How do you get total number of male cases? We have to first of all filter this particular n column that we have. So if gender is equals to male, then we are going to use this particular, you can see it, this particular code to filter for just males. So we are looking for gender is equals to male, and we sum that particular number. Same thing too also here. We are going to pick gender is equals to female, and we sum those gender. Once we sum those gender, then we can now get the number of male and female for both death and recover. So you can see number of male cases is this, number of female cases is this. So most of the times, these tables might look, somebody will be like, okay, why don't I just go to Excel and just do this? It's very easier when you're able to do most of these things in R, because most of the times you might be using some of these small tables for some analysis when working in a particular project. You want to get the total number of male cases that are dead, total number of male cases that have recovered, or total number of female cases that are dead, total number of female cases that have also recovered. So these are some of the ways we can get some of this little information. So the summarize function is very powerful, and you're able to apply a lot of filtering. You can also apply based on each category. I can say each category is equals to 0 to 4. Once you filter for each category equals to 0 to 4, then you give me the sum of the number of cases under that particular age category. So we have multiple columns. So this is, if you want to apply a particular function on multiple columns, we use the across function. Now this across function, it takes the argument .columns and .fns. So .fns is more or less like your function. So it's telling you that you should give the function you want to apply to all those columns. So what this across is going to do is that it's going to, after you have already grouped by outcome, the across is now going to apply the mean on both age of years, the age in years, the temperature, the weight, and the height. So it's going to create a new column for each of them. So for age in years, what is the mean age in years for death? What is the mean age in years for recovered? So this is what you have. For temperature, what is the mean temperature for death? What is the mean temperature for those that was recovered? Likewise for weight and also for height. And that is why you see we have this information that we have currently. There are various helper functions. Most of them belong to the dplyr that allows you to be able to create or apply some functions to your table. We have what we call everything. So We call them helper functions. They are mostly used when you are working with summarize. Mostly when you are working with summarize, you use these helper functions. Everything is going to select all other columns that is not what's mentioned. You can also have last column. Last column too also. Last column too also selects the last column. We have where. It applies a function to all the columns and selects those which are true. We have start with. You can say start with something. Start with date. Apply all this to a function that starts with date. Ends with what? Ends with something. Let's say ends with end. So instead of selecting functions like this, you can just say, for example, now let me give a typical example. Let me say starts with temp. Okay, I think let me see. Okay, I'm supposed to give this in quotation marks. So you can see this is just a typical example on how an helper function works. Because most of the times you'll be working with a data that might have 100 variables. You can't just be typing it. So helper functions are very important, and maybe when I'm sharing the resources for this, I can share the documentation. There is this cheat sheet for dplyr that contains all these helper functions. We have matches. Matches a particular regular expression. Contains age or contains time. We have end to it. So these are various helper functions that you can also use with your summarize data. So this is another example of an helper function. I'm using where. So where any variable is numeric, calculate the summary for me, calculate the mean. So this allows you not to apply a mean on a categorical variable. Because if I apply a mean on a categorical variable, it's going to return an error, or maybe on a date variable. So you can see these are all the numeric variables that I'm having. Are we there? Are we there?
Yes,
sir.
Here.
Okay. Now, convert long table to wider table. Now, that's what we call long and wide table. All these tables that I'm looking at before I proceed are just ways of extracting information from your data. Once you are okay with your table in R, the next thing for you to do is to rename it with proper names. It's always good you rename it in R. I showed how to rename it in R using the select function, something like this. Because the thing is that at times it's difficult maybe to run this code. Oh, where is it? Okay. At times it's difficult. Someone might look at it like it's more or less stressful to run this code. But the importance is that in terms when you face maybe a correction from a reviewer, a rejection, you can just go back, fix a little thing, and run the old code, run the old table, which is easier than going back to your table and editing it in Word every time a correction is made. More times, correction can be maybe from a data or maybe a category was done. So all of these are things that once you do, you are able to reproduce it. So once you reproduce your table, you are able to take it back to the Word document. So most of the times, if not because it's beyond the scope of the webinar, there's actually a way where you can even combine multiple tables. We have multiple tables, but I'm going to be treating that another day. We have multiple tables. You can combine them into your Word document. Once you combine inside the Word document, you don't need to be exporting your tables one by one. So you can also use the flex table tool for that. So I think I might just I might just share maybe an article on how to actually do that. That can also be better. Now we have what we call wide table or long table. So when a table is long, or if you want to convert, what it means by a long table means that, let's say we have a variable gender with male and female. Now That is a long table. If you want to convert it to a wide table, we are going to make male and female to be variables on their own. So we have the variable gender with male and female. So let's look at this line list. Now, when you want to make it a wide table, instead of male and female to be under the variable gender, male and female are now going to be standing as variables on their own. We have male on its own, then female on its own. So anywhere a patient is not a female under the male is going to indicate it as okay, let's say anywhere a male or a patient now is not a female under a male is going to indicate it as 0. If we have male and female now, anywhere a patient is a male, it will indicate it as 1. Anywhere a patient is a female, it will indicate it as 0. So we have already spread it. Now, where you are going to see how wide it is when you take, for example, a variable with 5 categories. For a variable with 5 categories, let's say it's an age category, that particular variable now is going to spread the number of values it has into columns. You're going to have a column age 0 to 4, age 5 to maybe 8, 9 to another value. So you're going to be having columns like that. Any patient that doesn't belong to that particular age is going to be indicated as 0. At times, you can find yourself conducting analysis where you need to spread your values. Most of the times, if you are using some machine learning algorithms, we actually call it one-hot encoding in machine learning. So it's one-hot encoding most of the times is what we do when you convert a single variable to various columns. So now if you want to convert a long table to wider table, this time around we are grouping by outcome and age category. So this is just our table that we have. I think we have already talked about this table earlier on. We just called age by outcome. So this is it. These are age by outcome now. Now what we are going to be doing in this place. We're now going to be making this age by outcome. Okay, we already have our outcome. We already have our age category. We're now going to be making age category. Each age category is going to be standing as a column instead of age category. So we call that function pivot wider. That's the name of the function. It's going to spread it. We are going to remove this percentage first. We are removing this percentage. I'm very sure you'll be wondering how we do with all these values. So let me run everything and compare. Let's compare so that you see how it's going to look like. So you can see the new table that we're having. Now, when it wants to convert this to a column, it's now going to give this particular value to it. So this particular value is now going to be what is going to be under it. This is the code. First of all, we remove the percentage using the select minus %. Then we use the pivot wider. The pivot wider takes 2 major arguments: the names from and the values. The names from is telling you that should you get the names of the new column. So the names of the new column are from the age category variable. This age category variable have factors. So those factors are the names that are going to be for the new column. Then what are the values? Where do you want me to take the values from? So the values is from the n. So under each particular age category, the new column I've created, you attach this value to it. So that's why you see dates under the row dates. Then column 0 to 4, you are going to have 471. Under the row dates, then column 5 to 9, you have 476, which is what we have in this place. So this is what is happening in this particular table that you are seeing. The number of cases with known outcome, deaths and recovered. So these are the number of cases with known outcome, the deaths and also recovered. This is also another way. I think we talked about something similar to this. Okay, I think we have already created a table that is similar to this. We group by gender and we summarize various outcomes. Let's say known outcome, number of deaths, number that recovered. So outcome where outcome is death, we are going to sum it. where outcome is recovered, we also sum it. So this is what we have. So at the end, this is the table that we're going to be having. So I've already talked about the janitor package functions. So this is outcome by hospital with group by and summarize. Outcome by hospital with group by and summarize. We have this filter. We have this group by to group the hospital by the outcome. This filter, we are removing missing values from the outcome and also the hospital. So in the data sets, some will be indicated with missing, that is in characters, while some will be indicated with NE. So that is why you see we are using this particular ampersand and hospital not equals to missing. So this is on its own, and this is also on its own. Then we now group by outcome. So let's see, what do we have? So most of the times, okay, by hospital. So this is it. We have already grouped it. Then we are now going to change our summarize. We are going to be looking for N and also the blood count, the median blood count. When we run this, so this is it, our summary, which is the N, and we have the median blood count value. So this is what's based on the summarized data. We have the totals, line lists, filter not is.na outcome and hospital not equals to missing. Same thing also we did earlier on. We are going to group by outcome. Also, we're going to be able to print by table. Same thing too also that we just did earlier on. This time around we are doing it by outcome. Earlier on we did it by what? The hospital. And we can also bind the rows together. If we can bind the rows together, if you look at this, you can see that this is the bind rows. The bind rows allows you to join two data with different rows. We have by hospital. Where is the by hospital that we did earlier on? And the totals is this particular table. So we are binding it by what? The rows. When we bind it by rows, we should have this. Okay, let me just run this. Okay, should be having totals. Okay, I think I know where the issue is. Okay, I know where the issue is. So we're trying to combine them by rows because they have similar columns, N and CT value. So if you look at this now, we're having our total, death and recover, the outcome. If you look at this, we have 3 columns. Here we have 4 columns. The thing they have in common is that they have outcome, N and CT value. So what we just did now, we just bind them together. So that was why this was showing NA earlier on. Because when you bind it together, this one doesn't has a hospital. So when you go to it, this is it. You can see it's the same values here because we joined the rows together. So it doesn't have a value of hospital. We are binding it together. So we have to now replace it with what? With total. That's what we are replacing because it's actually what? The total. It's more or less like the total for each of those particular hospitals that we have earlier on. So that's why what we are replacing. So this is also another way we can use bind rows to join two data frames together. So if you want to make a table wider, we have, first of all, we have to what? Mutate. For example, now let's start. So hospital, anywhere that's this particular table long we just created earlier on, we're still working on this data. We're trying to apply pivot wider to it. This same data, we're still working on it. So we're going to replace the hospital with the any, which I've already done earlier on. So it's just more or less like repetition. Then pivot wider. So this is the pivot wider we're applying. Now, this pivot wider now, any values, the values are going to be gotten from what? This and this. Why the names, the new columns we're going to be creating are going to be what? Death and recover. Those are the new columns we're going to be creating. When you run this, you can see that we're having CT value death, CT value recover. So the reason why we're having this attached to it is because we're having two values for each particular outcome. So the names is from the outcome. Then each particular outcome, we have that of CT value. We also have that of what? N. If I should say that of N only now, I'm going to see that we are going to be having deaths and recover. So Central Hospital 22 deaths and we are Central Hospital 22 recovered. Are we there? Are we there?
Yes, sir.
Okay.
Yes, sir. Yeah.
I thought the link has expired again. Okay. Okay, so that's it now. So if I now put back the N, you can see that we have CT value death, CT value recover. So for each of that outcome that we're having earlier on, it's going to take its respective value. So it's more or less like we are creating a column, a new column, CT value death with all of these values. Then CT value recover. Then we have N death, we have also N recover. Because we have two values, that's why we're having 4. So it's more or less like 2 times 4. So if we should have 3 now, we're going to be having how many? So let's say we have 3 of this, so we're going to be having 6. So 2, since the outcome is 2 for each of these, since the outcome is 2, and we have these particular numeric columns. So because it's more or less like it has transposed the data from a long format to a wide format. When you convert data from long to wide, nothing changes, it still remains the same thing. It's just more or less like the shape of your data that is just going to change. So this that you're looking at is still the same thing as this. The only thing that just changes is just the shape. You can see that most of the the variables that we're having are numeric. Unlike in this one where we have a single variable which is outcome. So we just spread the data to have our outcomes as columns on their own. So mutate now, we're going to use the mutate function now to change or to add them. So if you look at this now, you can see the number of deaths and number of recover. We are going to add 2 of them to form number of known. For the PCT deaths, we are going to I already explained that we did this earlier on. Number of deaths divided by number of unknown. That is what the percentage of cases that died. So how many people died divided by number of known, because number of known is the total together. So this divided by this will give us the percent. This divided by this also give us the percentage. If I run this now, okay, where was I? I think I've gone up. Okay, this one. Okay, if I should run this now, so you can see our percentage recovered, percentage dead, the known, the recovered. So then we now use the select to select the necessary columns that we need. So once we use the select, we're going to select the ones we need. We need hospital, number of known, number of recovered, percentage that recovered, the CT value recovered, the number of deaths, the PCT deaths, and also the CT value deaths. Then we now arrange. So arrange is mostly going to arrange in alphabetical order, the columns. So okay, sorry, it's not the columns, it's supposed to be the rows. The rows from the lowest to the highest. It's going to arrange it. So it's making use of the number of known. You can decide the variable to arrange with. So when you use the arrange, you are going to arrange a particular variable which is going to decide for all any other columns inside that particular data. So this is in what? Ascending order. You can also give it in descending order using the arguments. I think it's going to be this is equals to true. I think this should be the argument. So okay, this is equals to false, sorry, or it should be false. You want to arrange from the highest to the lowest. Okay, I'm trying to see why it's not. Let me check the function to see the right argument. Arrange. Okay, I think I know where the issue is. It's not actually an argument, it's more or less like a function you use inside. So this is going to be in descending order. So you just arrange this to be in descending order. So you can see now it's starting from the biggest, which is actually the total, then the hospitals itself. Okay, so now the gtsummary package. We have the gtsummary package. It's used to make a simple descriptive table, the gtsummary package. It's more or less a way to simplify all what we have been doing earlier on. You want to make a simple descriptive table, you just use your TBL summary. In fact, it's simpler than all what we have been doing earlier on. I think this class might soon take. Should we end it and start a new one? Hello, should we end it and start a new link? This might soon expire. Share it in the group. Hello?
Yes.
We do that.
Yes.
Okay, let me just end it and start a new one. Okay. Can I proceed? So we have the GT summary package. This is easier than all what I've been doing earlier on. But most of the times it can also serve its purpose, especially if you are doing something complex. But you can also use it if you know how to use it well. So it's very comprehensive. And in fact, it allows you to create publication ready plots directly. Look at how simple this is. We are going to use this to create a simple descriptive table. First of all, we are selecting the age in years. That is the tables that we are interested in, or the columns that we are interested in. We are going to select the columns that we are interested in, which is age, years, the gender, the outcome, fever, temp, and the hospital. So when you run it now, so it can take a little time. So you can see what we have. Is everybody seeing my screen? Can everybody see my screen?
Yes.
Yes. So this is how the GT summary package works. This is the median age, and this is more or less like the range. So unknown is those that are missing. That is the way you can actually set this or remove this. This is the gender, but this can also be important to allow people to know that not all of your variables are actually complete. We have this female and male. We have outcome, death, recover, unknown. We have fever. We have temperature, the hospital. So you can see how it is. So this is how the GT summary package works. The GT summary package, we can also use a particular statistical test in the GT summary because it has a lot of statements. Please, can you mute your mic so that those that are in the meeting could be able to concentrate? So you can also use various statistical tests inside the GT summary package. Look at this. We are selecting only age in years. And we have the TBL summary is the key function in the gtsummary package for creating descriptive tables. We have statistics which goes to age, yes. We use this tilde to tell it that we're interested in the mean. What he gave us earlier on was median. This place we are telling gtsummary that we need the mean, not the median. If I should run this, it's going to be different from what we have. You can see the mean is 16. So this is I'm just applying this on a single variable. If I also want to get the minimum and maximum, which we saw earlier on, only, you can see 0 to 84. This is the minimum and this is the maximum, age in years. Now, we want to modify the original table we created earlier on. First thing we do was to select the variables we're interested in, which is the age in years, the gender, the outcome, fever, the temp, and also the hospital. That's the temperature and the hospital. Next, we now pipe it to our TBL summary function. This is the TBL summary function. It has a lot of arguments that you can use to customize your table inside. It is inside this function you're going to customize your table name, your variable names, your category names. Look at it. Statistics. We have this argument called statistics. Okay, let's look at this by outcome. What we are telling it to do is that our dependence variable is the outcome. So make use of that as our outcome when we are going to use all other independent values. So any other values you see, they're actually an independent variable, or they're actually a factor of this particular dependent variable. That's what that by means. Then this statistics means that what kind of statistics do you want to give it, or do you want it to provide for your continuous and categorical? Because those are the two variables that you're dealing with. For your continuous, all continuous should provide mean and standard deviation. So you can see these curly brackets come again because we are referring to a function. So any variable that is a continuous variable, that is a numerical variable, provide the mean and the standard deviation. All categorical variables, then what are going to do, you are going to take the n and divide it by the total number of n, and you also give the proportion in percentage. So this is how you provide that of categorical variables. Then these digits is a way of formatting your digits. Do you want it in 2 significant figures, 1 significant figures, or 3 significant figures? This is where you specify it. All continuous should be in 1. Then the type, all categorical, should be termed as categorical. Then we have your label. This label is where you now correct the names of your columns. So this age years is now going to become age, then in brackets yes, your gender, your temperature, your hospital. So you are more or less like relabeling it from the way it was in the data set to how it's supposed to appear in the table. Then you now run this. So sometimes it takes longs when your data is very large. So this is what we now have. So you can see, let me maximize it. You can see this is our table. And this is the total number of females, the total number of males. So this is, so actually what we did earlier on here, we did not actually divide it. So we just gave the total number of females / the total number of the female plus the males without missing values. So we just want anybody seeing this table to know that without missing values, these are the total number of female and males. Because if you can see that of the fever is different. The fever has 122 that is missing. I can see we have 2,460. So this is our table that we have. We have our mean here and standard deviation, mean, standard deviation. Under deaths, we have under recover. So you can see all what we have been doing earlier on using the dplyr is already simplified in this place. So if somebody is comfortable with gtsummary, you can create your table directly from here. the next side now, you can now apply multi-line statistics for continuous variable. So you select your age in years, then your temperature. Same thing to also inside your TBL summary. All of them is continuous. So what we are doing here is that we are indicating that we want to print multiple statistics, not just single one. That's why we give continuous to. Most of these things are available on the documentation of the gtsummary, which I will also share. When you check it, you are going to see a lot of all of these functions, because most of what we are going to be using is inside this TBL summary. If you are creating a continuous, if you are creating a descriptive table, this is just for descriptive tables. All continuous. Now, which statistics do you want to apply to all continuous variables? So we are now indicating here that I want to apply the mean and standard deviation. I also want to apply the median, then give me the 25th percentile and the 75th percentile. I also want to apply the minimum and the maximum. So this already tell gtsummary that you need multiple statistics. So when I run this now, you can see that you're having multiple statistics. You have the mean, you have the median, you have the minimum and maximum, and you also have that of unknown. You also have that of the temperature, the mean, the median. You have the first and the third quartile, the minimum and maximum. You also have the unknown. So this is how you can use the TBL summary for your descriptive statistics. Then all what we have been doing also can also be applied in base R, but this is not something this is something you might just be using to explore. The base R has a function called table for creating cross tabulations. But in this place, we are just getting our number of outcomes. If you have a variable and you want to check how many are in each factor, the quickest way to do is just to use this particular table function. So once you run this table function, it's going to give you the number of observations under each particular factor for that particular variable. You can also use it here in this place to create a cross tabulation. This use NA means that it should count for NA. If you don't put use NA or you not give this particular argument, it's not going to account for NA. If you want to get a proportion table, use the prop.table. So it's the prop table that we just use in this place. So let's say we don't have the round. I just run it here. So this is the prop.table that we're having. Now, this margin argument lets you specify if the proportion is of rows or columns. Proportions can be of rows or of columns. If you look at this, this is of this. I think this should be of rows, because when you sum this, you have 1. When you sum all of these, you are going to have 1. But if I make it 2, it's going to be of columns. So when you sum all of this now, you have 1. You sum the whole of this, you have 1. You sum the whole of this, you have 1. So this is how you can set the kind of proportions that you want. I want to round it to two significant figures. You just run this. So this is it. So this is it, and 0.24, 0.32. You can see we have it to two significant figures, and you can see the proportion is is by row. So we call this the margin argument. So we have add margins, age by outcome. We have already created the table already. Age by outcome. This is it that we created this particular table. If you want to add margins, it's going to sum. So it's going to add a sum for you. So it's going to sum both by rows and by columns. I want to convert it to a data frame. You just, after applying your table, this FCT explicit NA, we are trying to remove NA. Earlier on, I showed you that, okay, let me just go to the FCT explicit NA so that I just see. So what it does is that it gives assign missing value to be a factor. So anything that is missing is going to give it something like this. It's going to change the name to something like this. FCT explicit is going to have missing. So you are now going to specify the NA level. Do you want it to be as missing? This is where you can indicate the kind of text that you want your missing value to take, because you can also put unknown if you prefer to use unknown. So with that FCT explicit level, you are able to signify that your factor variable has missing values. So this is a table. Then after that table, we add margins, which is your sum. Then you convert it to a matrix data frame. Then you convert your row names to column. That is age category. So let's do it one by one. So you can see we have death, we have recover, we have our missing. So now let's add the margins. Add the margins. We can, I think I've run it. Okay, we have our sum now. Then convert it to a matrix. So as data frame dot matrix. So we are converting, is a matrix format. So from matrix we are converting into a data frame. So this is a data frame. So this is a data frame. And row names to column. So these are our row names. These are our row names. So what this does is that what our row names, because it was from a matrix, that row names now became more or less like an index. So once we make it hard to identify that this particular row names is actually a column, and we gave it the name of age category. So if you look at it earlier on, you see that it wasn't having any name earlier on. Then flex table is what is now going to convert it into a Word document that you can export, or into an image that you can actually export. So this comes to the end of our webinar. I actually wanted to take, this is the descriptive aspects of the tables. So furthermore, we have the univariate and multivariate, and we also have the simple statistical analysis that you can also use, because the GT summary is not just limited to descriptive tables. You can also use it to get your logistic regression tables, your linear regression tables, your maybe chi-square tables, your Fisher's test table. So most of those tables you can actually use the GT summary to get it directly. So I'm going to be covering that in another webinar in the future, God's willing. Is there anybody with a question that I can attend to? Hello? Any question? Hello?
Yeah.
We can hear
Hello.
you, but no question.
Okay. So
Hello.
everybody is okay? If somebody have...
Please, can you hear me?
Yes,
I want to ask a question.
I'm hearing you. I'm hearing you.
I want to ask if you post the recording on your YouTube channel.
Okay, no problem. Okay, no problem. Okay.
All right. Thank you.
Okay. Okay. Is there any other further inquiry? Any further inquiry or question? Okay, I think all of us are clear then.